Imagine stepping out into the world one morning in the year 2055. You're wearing a jacket made from a fabric so advanced, so intelligent that it behaves almost like living skin. As you walk, a sharp edge of a metal railing catches the sleeve of your jacket, leaving a noticeable tear. In the past, this would have meant frustration, a ruined garment, a trip to the tailor, or throwing it away. But today, as sunlight warms the fabric, something remarkable happens. The tear slowly closes, the edges reconnect, the fibers relink, and within minutes, your jacket looks exactly as it did before the accident. No sewing, no repair shops, no waste, just a piece of clothing intelligently healing itself as if it were alive. Welcome to the future of self-healing materials. A revolution that begins with clothes but expands to every corner of our lives. This is not imagination. This is the direction in which material science, synthetic biology, nanotechnology, and artificial intelligence are pushing the world. But to understand how profound this shift will be, we must first understand the crisis we face today. Every year, humanity produces more than 100 million tons of clothing. Fast fashion accelerates consumption. People buy, wear, damage, discard, and repeat. The average garment is worn only 7 to 10 times before ending up in a landfill. Mountains of discarded clothes grow in deserts. Oceans choke with synthetic fibers, and microplastics from our clothing enter the air we breathe. The fashion industry generates more carbon emissions than aviation and shipping combined. It consumes massive amounts of water, chemicals, and labor. And yet most damaged clothes end up in the trash simply because repairing them is inconvenient or expensive. Self-healing materials have the power to change this story forever. Now imagine the early scientific roots of this technology. Researchers studying the skin of salamanders, which can regenerate limbs, the bark of trees, which seals itself after injury, the structure of spider silk, which can repair microfractures, and the complexity of human skin cells, healing cuts. For decades, scientists wondered if nature can repair damage autonomously, why can't the materials we use in daily life do the same? In the 2020s, breakthroughs emerged. Researchers developed polymers, special plastics that could reconnect when exposed to heat, light, or pressure. Then, the discovery of microcapsules began a new era. Tiny capsules embedded in materials that break open when damaged and release healing agents that fuse broken fibers back together. Later, protein-based materials emerged, inspired by the elasticity and molecular memory of natural tissues. These materials did not simply glue themselves together, they reorganized and rebuilt at a molecular level. But the real revolution exploded in the 2030s when scientists combined synthetic biology with nanotechnology. They created fabrics infused with engineered proteins that behave like living cells, detecting damage, migrating toward it, and repairing it automatically. Clothes began to act as semi-living systems. They could sense stress, anticipate fatigue, and reinforce weak points before they ripped. Garments lasted 10 times longer than traditional clothing. Waste dramatically declined. Now picture walking into a store in 2045. You see shirts made from self-healing cotton blends, infused with natural proteins that reconnect when moistened. Denim jeans with microvascular channels carrying repair enzymes. Athletic wear that senses microscopic tears and repairs them after every workout. Winter jackets that mend abrasions with the help of body heat. Every garment literally regenerates. But the transformation doesn't stop at clothes. Imagine your shoes repairing scratches on their surface, your backpack healing torn seams, your tent repairing holes in harsh outdoor environments. Even your furniture, curtains, car seats, and sofas regenerate. You no longer throw things away, they fix themselves. This shift dramatically reduces consumption. Landfills shrink, water usage drops, pollution decreases. Fast fashion companies collapse or evolve. High-quality products become affordable because they last longer. Clothing becomes an investment, not a disposable item. But now let's explore the science behind this in more detail. Self-healing materials operate through several advanced technologies. Some use reversible chemical bonds, tiny molecular hooks that detach when broken but reconnect when exposed to heat. Others use microcapsules that rupture on damage and release healing liquid that solidifies instantly. More advanced ones use living cells, bacteria or engineered microorganisms that grow new fibers. The most futuristic use nanobots, microscopic machines that crawl across the fabric repairing fiber networks. Imagine nanobots programmed to patrol your shirt like microscopic repair technicians. They detect stress, strengthen weak points, rebuild broken structures, and communicate with each other like a tiny army of intelligent workers. These nanobots are biodegradable and powered by ambient energy, friction, sunlight, or body heat. Now imagine a scenario in which your jacket gets caught on a nail and tears significantly. Instead of panicking, you simply wear it normally. Overnight, the nanobots activate, recognizing the structural imbalance. They begin aligning polymer chains, stitching the torn edges, fusing fibers, and restoring tensile strength. By morning, the tear is gone. This is not magic, it is engineering that mimics nature. But the true evolution of self-healing materials emerges when they become adaptive. Imagine owning clothes that become thicker when cold, thinner when hot, stronger when stressed, lighter when relaxed. Clothing transforms from passive fabric to active, intelligent armor. Athletes wear suits that tighten around muscles for support. Construction workers wear jackets that harden on impact. Military uniforms regenerate and strengthen automatically. Astronaut suits heal damage from micrometeorites. And imagine the next leap, clothes that heal you. Self-healing medical fabrics contain drug delivery systems that release medication when torn or activated by pressure. Bandages regenerate while promoting wound healing. Smart fabrics monitor vital signs and adjust therapeutic responses. Hospitals use sheets and gowns that self-clean and repair, reducing infection and waste. But as astonishing as this future is, challenges also emerge. What if self-healing clothes become too durable, limiting fashion trends and reducing economic turnover? What if nanobots malfunction? What if engineered proteins cause allergies? What if bacteria overgrow? Scientists develop strict safety protocols, kill switches, biodegradable nanobots, non-replicating microorganisms, and environmental shutdown triggers. But as safety improves, adoption accelerates. By the 2050s, self-healing materials extend far beyond fashion. Picture your home in the future. Walls that heal cracks after earthquakes, floors that regenerate scratches, cars that repair dents, airplane wings that fix microfractures during flight, pipelines that self-seal leaks, electrical cables that restore conductivity, spacecraft that repair radiation damage. Infrastructure becomes resilient, long-lasting, and self-sustaining. Cities become living organisms capable of healing themselves like a biological system. Now imagine the global impact. Industries shrink their carbon footprint. Waste becomes negligible. Repair shops transform into monitoring stations. Fashion becomes slow, ethical, and sustainable. Garment workers shift to new roles, programming fabrics instead of stitching them. Landfills shrink dramatically as clothes last longer. Economies stabilize as the cost of replacing damaged goods decreases. But the most powerful impact is psychological. Humanity stops seeing objects as disposable. We begin treating belongings as companions, not commodities. People value durability over novelty. Children grow up in a world where broken things fix themselves, and this changes their relationship with materials forever. Imagine a child in 2070 watching a tear disappear from their shirt. They ask their parent, "How does it do that?" And the parent replies, "Because we finally learned from nature. Everything is designed to renew, not to waste." This simple idea changes culture around the world. And this leads to the most important realization. Self-healing materials are more than a technological achievement. They are a philosophical shift, a movement away from throwaway culture toward regenerative living. The question is not whether self-healing materials will save the planet. The question is whether humanity will embrace this new way of thinking, where materials behave like living systems and where regeneration replaces destruction. If we do, future generations may look back at our era and say, "This was the moment humanity stopped breaking the world and started repairing it." Hi, I am Dr. Mohsin Raza, and thank you so much for watching the video, and don't forget to subscribe the channel.